In this video, I'm going to talk about the ambiguous case in solving non-right triangles. So if you remember from geometry, we had these angle, side, angle, and angle, angle, side, and side, 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 and side, angle, side. These are all different like pieces of a triangle that we know. So angle, side, angle would be a triangle where you have, you know that this angle is say 30 and this angle is 68 or something like that. And then you know this side is 5. So you can see that the side that I know is between the two angles that I know. So that's why we call it a side or angle side angle situation. And then this one, angle, angle, side, that would be where like if I had a triangle where I knew this angle was 42 and I knew this angle was 95. And then I knew this side was 5 or whatever, right? So again, notice in this case, the sides between the two angles I know. In this case, the sides not between the two angles I know. So, and then of course, side, side, side would be I know all side angles, or I mean, I know all three sides, I mean. And then side, angle, side would be a case where I know this side is 5, this side is 6, and then I know the angle in between them, like 45 or something like that, okay? So then there's a fifth case that's side, side, angle. And that would be where we also just know one angle and two sides, but we know the angle here, say this is, say 35, and then we know this side is 8, and this side here is 6, okay? So again, we know two sides of an angle, but the angle's not between the sides. So this is, in this case, these two cases here, we can use law of sines. These two, we have to use law of cosines, which we'll talk about towards the end of this, or maybe in a new video. And in this case, we also use law of sines, but it's what is called the ambiguous case, because in all of these, there's only one triangle that can be formed. So we just have to find the one triangle. In this case, there's a possibility that there might be no triangles, 0 triangles. There could be one triangle, or there could be 2 triangles. Depends on the situation, okay? And so we're going to look at that real quick. You could see in this case that it's very possible that I could draw another triangle that looks like this, where that's 35, that's 8, and that's 6. So you can see this has the same information as that one, but it's a completely different triangle. Because what has happened is this side of 6 is just swung inside and sitting over here, if you will. Because this bottom side down here is not set. It can be any length it wants, because we only know that this is 8, this is 6, and that angle is 35. So this side is set in its position, but it's not set in length. So that's why when we have the angle side side situation, there's a potential for 2 triangles. Now, why would there be no triangle? Well, if I had a situation where I had, say, 60 degrees, and this is 10, and this one was 2, you could tell there's no way that could reach down to the bottom, right? So that would be a situation where there is no triangle. And why would there be only one triangle? That would be if this side over here is too long. So we've had, say, 35 again, and this is 8 again, and this side here is 42, right? There'd be no way for the 42 to slide back in and fit over here on this side. So that'd be a case where there'd only be one triangle. So now that you visually get an idea of the possibilities, let's go back and solve this, this triangle here, where I have 35 degrees. I have 2 sides. One's opposite the 35, one's next to it. Okay, so if it's side or angle side or side side angle, first thing we do is observe that that's the ambiguous case. So we got to be careful, be aware that there could be 0, 1, or 2, and then we go after it. Okay, and the first thing you do is you use law of sines to find this angle down here, or possibly this angle, but it's going to be that one. Okay, so then I would go sine of 35 degrees over 6 is equal to sine of, and let's just call that A, sine of A over 8. Of course, that enables me to solve for A. So I'd go 8 times sine of 35 over 6 is equal to sine of A. And we put that in our calculator, so 8 times sine of 35. Make sure you're in degree mode because you're talking about degrees here. And divided by 6. And I get approximately 0.7647, etc., 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 equal to sine A. And then to solve for A, I just take inverse sine. So I'm going to leave this in my calculator, and I'm going to do second sine, second negative, and I end up with 49 degrees, well, 49.9 degrees is equal to A. Okay? So now, here's the key that you have to understand about this. When you find the 49 degrees, that's clearly a acute angle. So that's going to be this triangle up here, 49 degrees. And so we're going to call that A1. That's the first, or that's the angle A from the first triangle. So how do we know if there's a second triangle? Well, let's back up a second. How do we know that there's one triangle for sure? Because we got an answer here. If there would have been no triangles, we would have got an error right here. We never would have got past this step. You would have either noticed that this was bigger than 1, so knew you couldn't take inverse sine, or you would have just went ahead and took inverse sine and would have said error. Okay, so we know that this is not 0 triangles. We've got at least one triangle. How do we test for a second triangle? Well, we hop over here and say, notice that there's 2 ways to think of it. When I take inverse sine, I get a 49 degree angle. But notice if we think about the unit circle, there's an angle over here that would also work, right? With a reference angle of 49.9 degrees. And that would be this angle right here. So, and of course that angle is 180 minus 49.9. So if I wanted to get A sub 2, in other words, capital A in the second triangle, it's just going to be 180 minus 49.9, which would of course be what? 130.1? 130.1, okay? And so that's, now we still don't know if there's actually a triangle there. Our final step is to find the third angle here and make sure there is one. If the second triangle doesn't work, then these 2 angles, the one we just found in 35, would add up to be more than 180, which means there'd be nothing left for the third angle, which means the triangle couldn't exist. But notice here, if we add, so if we add 130.1 to 35, we get 165. So let's call this, say, angle B just for fun, which means that's also angle B. This will be angle B1, this will be angle B of the second triangle. So that means that angle B is going to be 180 minus 130.1 plus 35, right? Because I'm adding these 2 together and subtracting that from 180 gets what's left for there. So that's going to be 165.1, so that would be what? 14.9. So B2 would be 14.9 degrees. And the fact that I got something that wasn't negative means that that second triangle does exist. So this is a case where we have 2 triangles. And when there's 2 triangles, we've got to find all the parts for both triangles. Okay, so down here, so this we have B2. Let's go back over here and find B1. B1 is going to be found similar to B2, where I'm going to go, let's see, that's going to be 180 minus 49.9 plus 35. So that'd be 85. Let's see, so B sub 1 is going to be 95.1 degrees. Right? Because that would be what? 70. 84. Yeah, 84.9. So that'd be 95.1. Yeah. And then we just have to find side B, which would be this guy over here and that little guy right there. I don't know if you've picked up on this yet or not, but usually the way we number triangles is we use capital letters for the angles and then the lowercase letter for the opposite side, or sometimes we use the matching Greek letter for the opposite side. But generally when I do it, I use a capital letter for the angle and the lowercase letter for the opposite side. So this is angle B, that's side B. Okay, so let's find side B. So we're going to go back and use the same law of sines. So we take sine of 35 over 6 is equal to, and now we're going to use, we're looking for side B, so we're going to go sine of 95.1 over lowercase b, and that would be 1. And we're going to do the same thing over here. Sine of 35 over 6 is equal to sine of 14.9 over lowercase b. Okay, and then we'd solve that. So in the end, we're going to get b sub 2 is 6 sine 14.9 over sine of 35. And over here, b sub 1 is going to be 6 sine of 95.1 over sine of 35. I'll throw out my calculator real quick. 6 sine of 14.9 divided by sine of 35. And I get 2.69 approximately. Very short, which is not surprising. We expected that guy to be short. And then over here we get 6 times sine of 95.1 divided by sine of 35. Then we get b sub 1 is equal approximately to 10.42. And that is the ambiguous case. So keep in mind, just run up here real quick, if it was no triangle, we would have got an error when we tried to find that first A, angle A. And if there is one triangle, then when we went over here to find angle B, so there's the angle, there's the second angle A. When we went to find B, it would end up being negative, which means, of course, it doesn't work. So that would tell us that only the first triangle works. Okay? So that is the ambiguous case. I'm going to finish this off by talking a little bit about law of cosines. When we have a triangle with side angle side, like this is 5, 40 degrees, and 8, let's say. Because we don't have an angle, we have an angle but no side opposite, and that's what we need for law of sines. We have a side and no side, or no angle opposite, and we have a side and no angle opposite. So there's no way to use the law of sines here. So we use law of cosines. And so if we, let's say, well, that this is lowercase c, because that's capital C, and we'll call that B, which means this is capital B, and we'll call that A, which means this is capital A. So we need to find capital A, capital B, and lowercase c. So the first thing I'm going to do is find lowercase c. So I'm going to put c squared out front, and I'm going to put 25 here. Well, let me write it so you can see what it is. So that'd be 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of 40 degrees. And if you look at law of cosines, you notice that the important thing is that the side that you have out front here is the side opposite the angle you have over here. And then these, of course, this side matches that side, and this side matches that side. So if you have C out front here, then this is A and B. If you have A out front here, then you have capital A here, and then these are C and B, etc. Okay? So then we're going to solve this. We know that C squared is equal to 25 plus 64 minus 80 cosine 40. And we'll go ahead and calculate that. That'd be 25 plus 64, enter, minus 80 times cosine 40. And we get C squared is equal to 27.716, etc., etc. Take the square root of that. And we get C is equal to 5.26. And so that tells me what C is. And now that we have C, we can use law of sines. Because now we have sine of 40 over the side opposite, 5.26. And we can set that equal to either one. Now, One other thing with law of cosines, when we go to find the next angle, because all we have left is A and B, because we just found C, right? It's important that you find the biggest angle last, because the biggest angle could be an obtuse angle. And remember, when we're using sines, law of sine, we're using sines, and arc sine will not give you a obtuse angle, right? Because the answer for arc sine is between negative 90 and 90. So, and we don't have to worry about that, because all we have to do is make sure we find the biggest angle last, and we'll just subtract the other two from 180 to get it. How do you tell which is the biggest angle? Well, it's the angle opposite the biggest side. So because this is 5 and that's 8, that means B is the biggest angle in the triangle. So I'm going to find A first. So I'll do sine of A here over 5. And of course, that would be 5 sine 40 over 5.26 is equal to sine of A. So I'm going to have to calculate that and then take arc sine. So that's 5 sine 40 divided by 5.26. Then I'll take arc sine of that. And I get 37.67 degrees is equal to A. And then to get angle B, I just add 37.67 and 40 together and subtract that from 180. So that'd be 180 minus 40 plus 37.67 degrees. All right, so that's the law of cosines and the ambiguous case.